Oops. That should be fine, I think. Yeah, there we go. So anyway, we're going to combine these like terms, right? 2x minus 4x. I saw a lot of different things here. That's why I always say focus on the coefficients. 2 minus 4 gives us negative 2x. Plus 4 stays the same, and the right side stays the same. What we did there was combine like terms. Now we're going to bring our variable terms all on one side and our constant terms all on the other side. And like we kind of talked about yesterday, there are some situations where you can tell which side is going to be an easier side for you to move your variable to. Always move it to whatever side creates a positive variable term. If we added x to both sides, we'd still have a negative variable term over here. But if we add 2x to both sides instead, now we've got a positive x on the right-hand side. Oops, that should be a 4. Right? See how we have that positive x, negative 1x plus 2x just gives us 1x. Then we can subtract 5 from both sides and get x is equal to negative 1. Right? Give me a thumbs up. Anyone get negative 1 all on their own for this problem? Ooh, a couple people. That's good. That's good. Totally forgot. Let me get these passed out real quick. 1, 2, 3, 4. Forgot how school works. I've been going for so long. Yep. All right. Over to number 2. Number 2. Did anybody have a little bit of trouble with number 2? That's okay if you did. It's understandable. It's a fraction problem, right? So things are going to get tricky. I will warn you, there is one problem on the interim with decimals in it. And it's going to be pretty tricky. I don't expect any of you to, know how to do that one because we don't really talk about decimals in this class. It's only 1 out of the 6 problems, though, so don't worry about it. And we'll see it today on the practice. But with a fraction, we're going to have to use the distributive property here with that fraction that's on the outside. Now, we don't typically have to do this, but here we do. Negative 2 on the left, 1/3 times x. Well, we can just call that 1/3 x, right? And then we have to multiply 1/3 by 3. What is 1/3 of 3? Does anybody know? 1, right? If you have $3 and I take 1/3 of your money, you now only have, or I took $1, right? 1/3 of 3 gives you 1. Okay, we've got the distribution done. You see we've got 2 sides of our equation here now. And we're going to have to fraction bust. Luckily for us, finding the LCD here is quite simple. What is my LCD for this equation? 3, right? There's only one denominator. So that's your LCD right there. Now, negative 2 and positive 1, both those terms don't have a denominator. What can we write in as a denominator for those terms? 1, right? We just put them both over 1. So we're going to have to multiply those terms by something that'll give us a 3 on the bottom. And because they are both over 1, they're both going to get multiplied by 3/3, giving us negative 6/3 equals 1/3x plus 3/3 plus 1/3. Essentially what we did here is we multiplied the entire equation by 3. We made it 3 times bigger just so we can cancel all these 3's out on the bottom and get a better idea of how we're going to solve this equation. Negative 6 equals x plus 3 plus 1. All right, almost there. Almost done. If you caught a mistake up to this point, go ahead and correct it with your red pen. Like I said, this one was a tricky one. I think I told you guys to skip this. No? Did I? I don't think I did. If I didn't, I apologize. But it's okay. Let's combine these like terms on the right. 3 plus 1 just gives us 4. Even though they're constant terms, that is still technically combining like terms because all constants are like terms with each other, right? Last thing we want to do, luckily, x doesn't have a coefficient. We don't have to worry about dividing. But we are going to subtract 4 from both sides. I drew that line in the wrong spot. Subtract 4 from both sides, we get x is equal to negative 10. X is equal to negative 10. And I totally forgot on number 1, how many solutions do we have for both of these problems here, numbers 1 and 2? 1 solution, right? Letter equals number, 1 solution. Yes. Yeah, I don't know where those are at. So, negative 10 there for number 2. Not even any need to make an LCD table here. We only have one denominator. Okay, I want to take a look at number 4. 5x minus 4, 5x. Yeah. Actually, no. Not number 4. We already did 2 no solution problems on the warm-up. Let's do number 6. Yeah, there we go. Number 6. And this is going to be something that you are definitely going to see on the interim assessment. So if you got your head down right now or something, just bring it on up for number 6, and then we'll be done, and we'll get going on the practice, okay? First thing we do, I see those parentheses. Immediately my brain tells me I need to distribute that negative 2. So we're going to keep our left side the same, but now we've got negative 2 times 2x, and we've got negative 2 times 1. Now this is where things can get a little bit tricky. When we're distributing a negative number and there's a minus sign in between, you may look at this and go, oh, my minus sign's right there. I brought it down from my original equation. That's all I need to do. But that's not the minus sign from the original equation, is it? That's the negative sign or the minus sign on the 2 out in front. So we still have to bring that minus sign down. Right? What's that going to give us? Well, negative 4x right there. And then negative 2 times 1 is negative 2. But because we're subtracting, we can think of this as 2 minus signs next to each other becoming a plus sign. And 2 times 1 just gives us 2. So you may get a drastically different answer if you're not being super careful with your minus signs, okay? If you accidentally only throw in 1 minus sign, you would find that this has no solution. That's not the case, all right? Be super careful of when you have 2 negative signs right next to each other. Now we can see negative 4x plus 2 equals negative 4x plus 2. That's interesting. It's the same on the left as it is on the right. We know right away that this has many solutions. But if we wanted to take it a step further, we can. Let's bring our variable term over to the left by adding 4x to both sides. These go away, yeah.
If we just see that like that, do we have to do the rest of the work?
Nope. Especially because the assessment is multiple choice. So if you see it, just bubble it in, you'll be good. All right? I'm not checking work or anything like that. But all the 4x's go away, leaving us with positive 2 equals positive 2. This is the opposite of what we saw in the warm-up this morning, right? We've got a number equaling itself. That gives us infinitely many solutions. All right? Any questions about number 6? I think we are feeling pretty good. Like I said with Blake here, once you get to this point, if you see that the expression on the left is the exact same as the expression on the right, it's many solutions every single time. But this is why I've talked so much about this. You got to be careful Because if you see that you've got a plus 2 on the left and a minus 2 on the right, your brain will tell you, oh, that's no solution. When in reality, it's the complete opposite, right? I say right a lot. Did anyone notice that? I feel like I say right a lot. Anyway.